Don't you wish your machines would just run themselves? Well, some machines do. Many new machines are being sold with fully automated material handling solutions. The machine does the specialized task that it was designed to do, such as turning, and then handles the material in and out of the machine. But like cars on the road, not all machines are new. In fact, most manufacturers have fairly dated equipment that is still chugging along extremely reliably, especially small to medium enterprises or SMEs. Most of these machines were designed with humans in mind, meaning that they were meant to have human operators who perform a wide variety of important tasks, such as identifying and organizing unfinished and finished parts, handling raw materials into the machine, work holding actuation, actuating safety barriers, and initiating the program or pressing the big green button, handling finished parts out of the machine, cleaning work holding, post-processing, and of course, quality control checks. So if we want to effectively automate a production process, we are talking about a lot more than just material handling. The automated work cell has to be designed so that most of the tasks that the operator previously did can be accomplished with a robot and other supporting equipment. We can come up with an effective work cell design by adhering to a few basic principles. 1. Decrease the cycle time for primary equipment. If the piece of equipment is expensive to run, or a bottleneck for the process, we want to time other tasks to the cycle time of the primary piece of equipment so we get the greatest utilization out of the primary equipment as we can. Number 2, optimize the layout. We want to optimize the layout of the work cell to minimize travel distances and to ensure that the robot can reach all pieces of equipment. 3. Optimize motion. Speeding up and shortening movement can help reduce cycle time, especially when we're talking about robotics. Slow movement, though, is still necessary in some parts of the motion for accuracy and consistency purposes, especially in the prehension or gripping stages of the motion. 4. Fixture everything. Absolutely everything. A robot is like you trying to find the light switch in the middle of the night. The robot can't see anything, but it knows where things are if they don't move around. It's really important that the robot does not move with respect to the machines and that the fixtures don't move with respect to the robot so that it can find the equipment. And lastly, 5, routine inspections. Even though you may have an automated process, skilled staff are still required to routinely inspect the work cell. There should be a maintenance program where certain aspects of the work cell, especially wear components, are checked, replaced, or recalibrated after a number of cycles. And with that, let's have a look at each task that is part of machine tending and see how we can automate it. A machine operator organizes the unfinished stock and finished parts out of the machine. Typically, an operator might loosely stack finished parts in a cart. Robots, however, need to be a bit more regimented about how parts are organized, and this can be accomplished with many aids. Here you've got feeders and ramps. This particular clip shows how raw stock can be arranged in a feeder or a magazine style feeder, so the robot can grab that stock and put it into the machine, and the remaining stock moves down into place ready for the next part. In this way, the robot does not need to go to a new place every time it needs to grab a new piece of stock. It returns to the exact same place at the bottom of the magazine. You've got conveyors. This clip shows the use of conveyors to transport finished parts away from the work cell. You've got cartridges, carts, and trays. Here's how cartridges and trays can be used to hold parts pre- and post-machining. Trays are often arranged in an upright position. This uses gravity to ensure the parts locate themselves in the right position on the tray. And typically you would teach the robot where the uppermost left corner of the grid is, and then the lowermost right corner. Tell it some details about the spacing and how many parts there are, and then the robot can easily find all the parts itself. In some instances, for finished parts, you can stack the parts in a bin when the part geometry lends itself well to stacking and you aren't too worried about the part surface finish. Stacking and palletizing. Similar to how robots can be taught how to grab raw stock from a tray, they can also be taught how to palletize and arrange parts in a grid. This clip even shows how the program grabs a divider so that it can palletize multiple layers of finished product. Bin picking. Picking parts out of a bin is relatively easy for a person, but requires sophisticated vision software to be able to do with a robot. There are many different methods to attack this problem. Some use special lighting and cameras, while others use laser scanning. Ultimately, the main benefit is that if you have a large number of parts, they don't need to be organized by people into nice trays in order for your work cell to begin working. On occasion, a vibrating table can be helpful to reorient parts for picking if they do not present themselves in an ideal orientation. I've seen some solutions that bypass fancy laser scanning of the pile by just grabbing a handful of parts and placing it on a vibrating table with a light and camera. Classical vision technology is very good at recognizing parts when there's only a single layer of parts, and the grasp orientation and location of the part can be determined very easily in this way. Cameras and barcode readers. It's not uncommon to integrate cameras and barcode readers into automated work cells these days. These are used for part identification and can read barcodes, data matrices, QR codes, or even .peen. Part identification is, of course, a very important part of quality control. In modern manufacturing, where consumers are demanding higher amounts of customization, or for manufacturers that need to adapt quickly to different types of parts, it is important because part identification can also drive what program is loaded into the machine. In other words, with some limitations, you can do mass manufacturing of custom parts with the same automated work cell. It's pretty easy to get carried away with automation, but at some point you do need human intervention to do maintenance, inspections, change out parts, change out stock, change out tools, change pallets. Of course, all of these things can be automated as well, but it's important to determine which tasks have real ROI and which tasks have real automatable value. End effectors. The choice of end effectors is an important decision for quality and cycle time optimization. Multi-ended effectors allow for multiple part handling, so finished parts and blanks can be loaded and unloaded at the same time. When the end effector can complete several processes, it saves on motion, trips, and tool changes. Many end effectors also incorporate pneumatic nozzles to help them with cleaning the fixtures. Force perception may also be important so that soft objects are not squished or to prevent marring of softer metals. In most cases, custom jaws for gripping end effectors typically help maintain more secure part holds and more accurate placement. For certain applications, vacuum gripping and magnetic gripping may be appropriate, and multiple specialized machines or multiple end effectors may help sync the timing of post-processing tasks with the primary process. Work holding. Typically, when parts are placed in a vise by an operator, a torque wrench is used to tighten the vise. This ensures a consistent clamping pressure, which is just one factor in part consistency. In machine tending, the most common solutions are pneumatic, such as air-powered motor vices, pneumatic vices. There's also some products that you can use to retrofit an existing vise. These are typically also pneumatic. There's also hydraulic vise solutions out there. The main goal with all of these solutions is to provide an automated vise opening and closing, as well as a consistent and reliable clamping pressure. It's much easier to actuate a pneumatic vise than to get a robot to turn the handle on a torque wrench. Sometimes an intermediary fixture is required when the robot needs to change its grip on the part during the process, or perhaps the robot just needs to put the part down so that it can grab something else. Either way, you don't want to necessarily just put it down on a table, because it's not going to give you a positive and exact position when the robot goes back to grab that part. So you want to use an intermediary fixture to store that part while you're doing something else. Quality control can also be part of the automated workflow. It's possible to incorporate deburring, polishing, sanding, washing, and other post-processing tasks as part of your automated work cell. One added benefit of an automated work cell is that several tasks can be executed simultaneously. For example, the door to the machine can be open at the same time as the robot grabs a very heavy object and moves it towards the fixture. Personally, I prefer to see the machines inside the work cell integrated closely together so that this can happen. It seems really silly to me when a robot has to open the door to the machine, for example, and press the big green button. These are all things that should be executed through the I/O. Combining your robot with gantry movement can also vastly increase the robot's reach and maximize the value of your investment. The gantry movement is shown here, but it is possible to use this to have a single robot manage multiple work cells if those work cells have long enough cycle times. I hope this has given you some insight into what goes into automated work cells and machine tending applications. If you want to check out my last video breaking down food prep automation and how it's helping restaurants reduce real estate costs. Check it out in the link down below. Please share this video with a friend. Thanks for watching, and again, I'm Stephen Bruce Wong with Automation Experts, and I will see you in the next one.